So the next example is cobalt complex, which is having 6 fluoride ligands. So basically, if you observe this one, this coordination complex is having a negative charge. So it is an anionic complex. The central metal atom, cobalt, having atomic number 27. So the ligands are weak field ligands. Fluoride ions are weak field ligands according to spectrochemical data. So weak field ligands won't promote pairing of electrons in inner orbitals, that is n-1d. From this data, so weak field ligands will form outer orbital complex or spin free complex or high spin complexes. So basically COF6 3 minus is a spin free complex or outer orbital complex. So next step is finding the oxidation number of the cobalt central metal ion. So here cobalt is linked with 6 fluoride ions. Each fluoride ion will have a single negative charge. So that's why it will be cobalt plus 6 into minus 1. So that is equal to overall charge of the complex is minus 3. So cobalt will be equal to 6 minus 3. So cobalt will get plus 3 charge. So oxidation state of the cobalt in the anionic complex is plus 3. It exists as CO3 plus ion in the coordination complex. So cobalt, whose atomic number is 27, if you write the general electronic configuration by simplifying, by considering the nearby noble gas configuration argon. So it will be Ar 4s2 3d7 4p0 4d0. So for our convenience, we will rearrange this to describe this complex. Ar 3d7 4s2 4p0 4d0. So cobalt is existing in the form of CO3 plus ion, means the cobalt atom is losing 3 electrons, from which orbitals it will release electrons, so that it will exist as CO3 plus ion. So probability is, so from the outermost shell, outermost orbital, that is 4s2, it will reduce 2 electrons, and from the inner orbital, from I can say second orbital of the d subshell of third shell, I mean n-1d, it will release 1 more electron. So total 3 electrons are released, so that cobalt will be in the form of CO3 plus ion cation. So in the CO3 plus ion form, the cobalt, if you see the expanded electronic configuration, so here 4s is 0, 4p is 0, 4d is also 0. But n-1d, that is 3d, will have unpaired electrons. This is the status. But for 6 ligands, cobalt 3 plus should provide 3 empty orbitals. 3 empty orbitals, so that it may receive 6 pairs of electrons from 6 different fluoride ions, right? So for that, fluorine can't influence the spin pairing of electrons in the inner orbitals, so that inner orbitals cannot be used for the bonding or the coordination bonding or dative bonding or linking by the ligands, so that the linking will be done through the outer orbitals, so that the outer shell orbitals like ns, np, nd. So here n is the valency shell, you can take, I mean the valency shell here is fourth shell, so that's why 4s, 4p, 4d are utilized for hybridization, so that we require 6 orbitals, right? 1 4s, 3p orbitals, and 2 d orbitals from the fourth shell are utilized for the hybridization to produce equal energy content 6 sp3d2 hybrid orbitals. These 6 3p sp3d2 hybrid orbitals are utilized by the 6 ligands fluoride ions to link with the CO3 central metal atom. So what are the parameters to describe the coordination complex? Means hybridization we have found sp3d2, geometry we came to know octahedral, magnetism because of unpaired electrons in the inner d orbital it is paramagnetic, and it will form high spin complex or outer orbital complex or spin free complex also you can say. If you take the IUPAC name, I mean hexafluorido, fluoride E is removed and O is added. That's why ligand name hexafluorido cobaltate, because cobalt is present in anion, complex anion. That's why E8 is added at the end, and whose oxidation state is mentioned in the form of Roman letters in parenthesis. That's why hexafluorido cobalt 8 3.